Good day, and welcome to our webinar on Sustaining Advanced Process Control Performance and Benefits. Today's program is brought to you by CFE Media and Technology and sponsored by Honeywell Process Solutions. Today, we'll be joined by Gary Jubian, a product line leader with Honeywell Process Solutions. I'm Kevin Parker, editor of Plant Engineering and other publications from CFE Media. Operation and maintenance of advanced process control applications can be complex. In fact, how so-called APC systems actually work may be understood by only a few. The profitability of a successful APC implementation, however, is well understood, even by the multitude. Money talks, but what's the best way to translate APC performance into dollar signs? Honeywell Process Solutions' answer is the Profit Performance Monitor, a cloud-based APC monitoring solution that enables operations, process engineering, process automation, and management personnel to better understand what keeps a process from achieving and maintaining peak performance. It improves collaboration amongst extended groups of APC stockholders, allowing them to proactively identify performance degradation and deliver the kind of expert guidance that maintains unit profitability. Stay tuned for today's presentation and discussion. You'll learn what the typical causes and economic impacts of APC performance degradation are, how the impacts of APC performance can be communicated to a larger audience at the plant, and how cloud technologies are being leveraged in the APC space. To get the best results from the webcast platform, please make note of the following as you participate in today's event. If you are having technical problems, click on the question mark at the top right-hand corner of your screen to bring up a list of system checks to make before escalating to an online technician. If you are experiencing issues with your slides or audio, please refresh your browser or click the Refresh Media button directly under the presenter's headshot. You can control the volume settings of this webcast by adjusting your computer or by adjusting the volume on the platform. If you do need a technician, type a message into the Ask a Question box and someone will get to you as quickly as possible. Answers to your technical questions will appear in the Answered Questions box. The Ask a Question box is also used to ask the speakers questions. You may ask a question at any time during the presentation. We'll get to as many as time allows. To download the presentation slides and certificate of completion, use the Event Resources box on the left-hand side of your screen. You can download the presentation and certificate until the conclusion of the webcast. The link will break when the webcast signs off. This webcast is being recorded, including the Q&A session. We'll send you an email message within a week with a direct link to the webcast archive. I'd now like to introduce today's speaker. Gary Jubian is Honeywell Process Solutions product line leader for Profit Technologies, which includes the Advanced Process Control Profit Suite, the Control Performance Monitor, and the Blending and Movement Management portfolio. In this role, Gary leads efforts to drive market requirements into technology development and product roadmaps. The Advanced Solutions-based portfolio instantiates strategies that combine capabilities for digital transformation, standalone software offerings, and real-time optimization. Gary joined Honeywell Process Solutions in 1991 as an advanced process control engineer. He has held roles that include America's Solutions Consulting Manager, APC Engineering Manager, Saudi Aramco APC Program Manager, and most recently, America's Aftermarket Services Leader for Advanced Solutions. Prior to Honeywell, Gary was a control engineer at Esso Canada. Gary holds a bachelor's degree in chemical engineering from the University of Waterloo in Canada and is based in Thousand Oaks, California. Gary, welcome to today's webinar, and please go ahead.
Kevin, thanks so much for that introduction. Very pleased to be here with you today and to talk a little bit about what we're doing in the advanced process control space. So I guess I would define this first slide as the problem we're trying to solve. So a quick review of what advanced process control is and what it does. We have a diagram of a process. The process has a certain degree of variability with a mean around baseline condition. The upward direction towards the process limit is the more profitable direction of the process. Ideally, we would like to go up there, but due to the higher process variability, we can't. So when we implement APC, first we reduce the mean, or the variation rather, and that's done by implementing multivariable control. So in an analogy to your car, that might be something like cruise control in your car, being able to hold the speed more closely. In this case, it would be more multivariable in nature, driving to a set of constraints, economic information in the control of pushing you there. And that upper level is where we would like to be and sustain in that region. So that step in the baseline condition to the mean in the upper level is what results in benefits of an APC project. And typically these projects are one of the ones that have the fastest payback at any site, often 3, 6 months, 12 months sort of thing. Very, very successful invariably. And I will say that when you have had APC presentations in the past, typically they'll stop at this point in the graph, but we want to take it a little bit further. And as Kevin mentioned, one of my roles was in the aftermarket services area. And one thing we did was we talked to a lot of customers that had advanced process control. They might have had it for 3 years, 5 years, or more. And what we saw is in some customers, not all, but a degradation in benefits over time. And although the initial project was successful, ideally we would like to see the customer stay at that successful higher delivered value point of operation. That was not always the case. So we started looking at how can we help customers to solve this problem. So one way of approaching that is to understand why are the degradations in the first case. So there are many, but I think it helps maybe to put them in these 3 categories. And the first category is significant process or operational changes that may result in mismatch between the predictive models, which are at the heart of the advanced process control application, and the process itself. Additionally, we may see a drift in the accuracy of what we call inferential properties. An inferential property in the APC space is a calculation that attempts to surface a value that's not easily readable from the process. So that might be in a distillation tower, the percentage of heavy key in the top of the tower, for example. I might not have an analyzer, but I would have temperatures and pressures, and I can do a pretty good job in developing a calculation that predicts what that heavy key might be given the process and lab information. But over time, if that's not accurate, then the advanced control isn't necessarily delivering the benefits that it could be. The third case with significant process changes is that you may actually have a missing manipulated or control variables in the control matrix. And by manipulated, I mean that's what the APC is actually adjusting, and control, self-explanatory, that's what we're trying to control. And if they're not in the matrix, not in the control, we're going to have issues. Either the operator is going to turn the controller off or maybe partially disable it to account for that. And I should say that most APC technology today, regarding the first point about model mismatch, they're quite pragmatic and quite robust. I know for our own technology, an APC model that might have a 25–50% mismatch, let's say in the gain or maybe even the time constant of a process, will still continue to work pretty well. So they have to be significant process or operational changes to experience that degradation in the models and perhaps oscillatory or overly slow tuning. The second area is around APC usage practices. And although typically an advanced control is designed by, let's say, someone with a process or control engineering background, the end user of an APC application is an operator, someone typically who is at the distributed control system console. They're the user, right? The engineer is the mechanic, and the operator is the driver. And what we see over time is that the limits, the kind of handles and direction that the operator may give to the advanced control may tend to drive the controller to operate in a safe zone. The reasons for this are varied. Sometimes it's a very good reason. There's a temporary process upset adjustment might have been made to a limit, and it was the right thing to do at the time. But if you looked a couple of days, weeks, months down the road, those conditions were never really returned to the proper baseline conditions that would be necessary to achieve the benefits that we hope to capture with APC. So these are all sort of different flavors of the same thing, but running in a safe zone, selectively disabling manipulated or control variables, so keeping the whole application on, but selectively disabling parts of it, turning APC off entirely, that's pretty clear. If that gets turned off, then you're not really going to capture too much as the process moves on. And we mentioned the upset or maintenance. Also, typically most plants where APC applied, they're 24-hour plants, 24/7. You have different shifts, 8 or 12 hours typically. And while one shift may be using APC in a very good way, another shift may not. Shifts may have differing opinions about how the process operation is best used, and that can drive lots of changes to the APC that are generally not that good. And all of those issues generally fall to a control engineer, maybe an operating supervisor, to drive best practices in APC usage. So they're addressed through training, that item number 2. The third item, which related to number 1, but sort of a slower creep on that, is slowly integrating process or equipment degradation that over time just means the process window tends to shrink. And, moving the limits in that case, it's the right thing to do, but not always full appreciation for the impact of doing that. So I would advocate that most people know about item number 1. It's typically addressed periodically, maybe in a turnaround or some significant event occurs that drives the remediation activities. But I would say that often number 2 and number 3 may tend to go addressed while significant degradation occurs. People sort of live with it, they're not aware of it. And that's where we see when we audit those applications down the road, several years down the road, that the APC degradation has really occurred. So let's think about how today APC maintenance is performed or troubleshooting is performed. Step 1, first of all, the control engineer has to realize there's a problem. Not always that clear. As I said, maybe these conditions have been the case, maybe since they came into the position, certainly for days, weeks, or months, and may go undetected. But let's give them the benefit of the doubt and say, they're aware of a problem. So how do they troubleshoot? They analyze APC performance, maybe run some trends, pull some data, go out, talk to operations, investigate a bit more, and then kind of put together the insights and come up with recommendations and actions. And the issue with that workflow is that it's manual, time-consuming, and reactive. And ultimately, the benefits of the control engineer are unclear and certainly unquantified in most cases. What we really like to do is systemically address the problem so that it wasn't occurring time after time. I know, as Kevin mentioned, I started my career with ESSO in Canada, and it seemed quite often I would come in the morning or maybe at the start of the week and look over the APC and then have to go out and talk to the operators, get things back to where they should be. And that's kind of a burden on the engineer. And what we'd really like to do is maybe change that workflow a bit and allow operations to kind of self-service in a way so that all of the task and burden of APC maintenance didn't always fall to the control engineer. So what would help here to address this situation? So we felt like if we could develop a solution that could identify the issues when they occur, so I wouldn't have to go out and pull a bunch of trends and talk to people, that would be good. I'd also like to bring financial impact into the picture. I would say a lot of companies, Honeywell included, has had a crack at this general maintenance problem. And usually what we have done historically is we've given the control engineer more and more tools, more and more KPIs, more and more trends. I like to say that we always felt like we were just one KPI away from process control nirvana. I don't think we'll ever find it. What we need to do is really change the way the game is played. So leading into the third point, we want to present the information in a persona neutral way to enable for self-correction. So sort of a wordy way of saying we'd like maybe an operating supervisor to have the information when events occur that will lead to degradation. We want to quantify those, give them the information they need to correct them. Really, if you think about, there's a lot of interested parties in APC maintenance, not only the control and operations department, you have process engineering, management, etc. So we'd like to give them the same view of the APC issues and present it in a way that isn't just in sort of control speak, the way that we have done traditionally. We'd also like to contrast not only we've been talking a lot about economics, but one of the important benefits, maybe underappreciated benefits of advanced process control is that it is managing and addressing the constraints in at a facility. So we'll see a little bit how we incorporate that information and sort of the dual view and competing objectives of economic and constraint management. We mentioned shift-to-shift differences. We're going to pull some data around how various shifts are doing, not to get folks in trouble or score people poorly. It's really to drive training and best practices throughout all shifts. And further, people have tried to address this maybe with, as I mentioned, a lot of KPIs, a lot of trends. We wanted to take it a step further and actually provide specific actionable recommendations to restore the APC profitability. So not so much here are the KPIs, you go and figure it out, but we're going to tell you specifically what needs to be done and provide a workflow for doing that. So I would summarize this as saying that the benefit sustainment is not just a control engineer's problem, it's really something that there's a lot of interested parties, and I think they all have a role in helping with that. So our solution to this problem statement is called the Profit Performance Monitor. So Profit Performance Monitor, it's a web-based or cloud-based application that identifies lost opportunity, breaks down the areas in which those lost opportunities are happening, measures constraint management, compares operating shifts, and provides actionable recommendations. The program itself was initially designed to support Honeywell's advanced process control technology, but we have since broadened it to support any vendor's APC technology. So that might seem like a lofty claim, but the truth of the matter is most APC technologies are pretty similar in that they are based on a dynamic multivariable controller, something that's matrix-based, and on top of that controller, there's some sort of economic function analogous to an LP. So given that premise, we were able to develop a solution that was applicable to all advanced process control. And in fact, we've applied for 5 patents with the technology that's behind APC. I have detailed graphs of each section of the screen, so I'm not going to go into too much detail on this one, except that to see that everything is presented in the one screen. And I'll just state as well that the application itself, it's not sort of an empty shell in the sense that we just sort of give you something and then you have to put all the pieces together or configure it. It has a format that's really more of a configuration exercise. So we'll work with you to understand your controller design, your models. Since we do quantify benefits, we'll have to understand your economics. This question comes up sometimes. The economics can be normalized if you would rather not present the actual profitability of the application to other, some users. You can normalize it, say, divide the profit function by 10 or scale everything from 0 to 1. We think it has some value as it really quantifies a specific event, such as a limit change, and the value of being able to say that the restoration of a limit, let's say, will result in, let's say, $1,000 a week in increased profit. There's definitely some power to that versus, typically talking about KPIs as we tend to do. As I mentioned, there is a workflow, there are specific actions. Those are located in the lower right-hand corner, and I will talk about each section of this dashboard and talk about what we're displaying in each section. So the upper left-hand corner is really around long-term performance of the APC. There are a few lines, few data here. The most important one is the red line. So it has 0 axes there, and anytime it's above 0 means we've detected some sort of lost opportunity. So that's a 3-month trend with the ability to highlight 1 week of that trend. You can see on the right-hand side we have some gray shading, which highlights that particular week of interest. But the key thing is the longer-term trend, and anytime that value is off the x-axis, it means there's lost benefit, lost opportunity. And the causes are, as we discussed, maybe that's turning the APC off, partially disabling it, changing the limits. It's really picking up on those events as they occur. Other aspects of the longer-term performance, there's actually some detail in 5 of the 6 fields on the dashboard. There's sort of some drill down where you can get a little bit more information. On this particular one, we're actually highlighting in those 3 months what were the major contributors to the lost opportunity over that time period. In this particular case, the main reason was turning the APC off on the left-hand side, as we can see. But we're also highlighting that opportunity was lost as variables were dropped, limits were adjusted, etc. The next trend shows for the week in question. So recall, as we highlighted that gray area in the upper left-hand trend, we were focusing on a week of process data, APC data. And for that week, we'll actually draw a trend and show the variables that contributed most to lost opportunity. The blue line is the actual process trend, and the red line would be the ideal trend. So it helps to understand where some of the leakage of APC benefits are down to the specific variable area. I like this trend here. This is on a weekly basis where it's showing, again, the tie between lost opportunity and the types of things that are causing it. So we break that down into either control variable or manipulated variable limit issues, high variability, variable may be dropped, the APC may be turned off. So again, really to help to understand why the APC may be degrading and to provide information that can be helped to drive best practices, training, etc. We talked about training a little bit here. So here we had in the upper right-hand corner a longer-term trend, and we do think it needs to be longer-term around relative shift performance. So in this case, we're looking at 2 to 3 months of history, and we're looking at both economics and constraint performance. And it's really a relative value of how various shifts are doing here. So we might see that a particular shift is doing very well in maybe their limit management and really realizing excellent economic performance, perhaps at the expense of constraint performance or vice versa, etc. Maybe there's a shift that is just turning the APC off all the time, and we need to understand why that is, why the APC isn't meeting their needs. Do we have a training issue? Are they seeing something that maybe the other shifts aren't, that we need to address? A little more detail here on the shift performance. So we have some bar charts around the number of limit changes over time, the utilization of APC, etc. This is information that we typically have shared with control engineers in the past, but often presented in a way of, perhaps impenetrable KPIs for the common user of an APC application, let's say an operating supervisor or superintendent. So we're trying to use good design user experience principles to provide that information to someone who can make a difference, so that as I stated, not everything sort of falls to the control engineer to sort of pick up and figure out. We talked about the dueling aspects, dueling objectives of advanced process control around economic performance versus constraint management. So in this section of the dashboard, we'll actually collect from you for the unit or plant area scope, what are the 4 most important constraints that you're trying to have the APC address and maintain. So and we trend those. We trend, of course, with some factor that considers the variability of that. How many limit violations were there? How as in the previous graph showed, how are various shifts doing in maintaining those, etc. So It might seem to be inconsistent, perhaps, with some of the other maybe more benefit-driven aspects of the dashboard, but what we're really hoping to do is to make a more operation-centric dashboard, less sort of control-Z. So the operations need to be and are concerned about constraint protection. So we brought that in to give them maybe sort of a more complete view of the APC environment. Mention the workflow. So this is in the bottom right-hand corner. So we can see a couple of messages here. So if I take the first one, it's telling me that the APC has been turned off and needs to be switched back on in. And the next to last column actually quantifies the value of that. As I said, we can do that because we build a profit function for the advanced control. And when it's off or partially disabled or the limits aren't in the wrong place, we can actually calculate how much benefits are being lost. So there is a workflow here. This is showing some action items, some open items. It can be moved if they're being actioned. They can be moved to in progress state. If they're no longer relevant, maybe they have to wait for a turnaround to address something, we can actually shelve them. So a little bit around the action dispositioning. And just to preempt this question I sometimes get is, where are these recommendations coming from? Is this something that the customer needs to do? Is there a little person watching over their shoulder? No, these are generated with some logic. You know, if you want to get fancy, you could say it's an AI. Maybe I wouldn't quite say that, but certainly some pretty clever logic rules that identify the actions and provide them to customers so that they can recover benefits. So sounds like a lot of stuff going on here. Why is this worth doing? What is optimum usage really worth? So here we have a trend of 3 months of time of an APC application that was initially, or sorry, it's 3 years of time, APC application initially delivering an annual benefit of 3.5 million. It may seem like a lot. Maybe it is high for your site. Maybe it's low for your site. I can tell you that in an oil refinery, a single unit like a cat cracker or crude unit could easily have this sort of benefit after commissioning, even an average size unit. So what the red line shows is that over that 3-year period, if all you do is you lose 5% of the benefits annually, it actually accumulates to a loss of over 600,000 in that 3-year period. So we would say 5% of the benefits degradation due to things that we can fix, right? Like not because the process is, you know, or the APC is not runnable because the process has changed so much, but just driving better APC usage amongst operations, more awareness around the operating window, and keeping the APC running as well as it was the day it was commissioned. You know, our data, our sampling of customers, seeing where they're at, would support that 5% per year is probably a reasonable number for this type of degradation. So it's definitely worth going after. We'd rather, frankly, see our customers running their APC really well, right? It's a great advertisement for our products, and we would like to do more APC with all our customers. So we have a vested interest in solving this problem and helping customers to retain benefits. So a little bit around how do we do it. It is, as mentioned, a cloud-based application. So the footprint at the site is really pretty light. Typically applications, let's say APC monitoring applications, might be installed at an L3 or L4 level. What we're doing in this case is just collecting some historical data in the L4 historian. It's actually a significant subset of the data in a typical APC application. So what are the limits, etc. We capture them. We safely transport that data to Honeywell's Azure cloud environment that we call Sentience, or Forge now with our current branding. Then we kind of reverse the process. We take that data, we put it in a cloud-based historian, we analyze that data, we do the analysis, we show that dashboard that we're looking at, and as a user, you actually would simply start a browser session, log in, you get a specific login for yourself, and you would be able to interact and view that dashboard that I saw. So again, why cloud-based? We'll talk a little bit about that on the next slide. So some of the benefits, and these are general benefits of cloud-based applications, but having a single instance and having the software instance always accessible to us allows us to put improvements, fixes, etc., into the software much more frequently than it does our on-premises software, which typically we would follow maybe a year to year and a half between major release cycles. We think we would do much more frequently in the case of the cloud-based application. As mentioned, the IT footprint at your site is lessened. There's no big server to run these calculations. It's just collecting data, typically at the plant information network or L4 level from a historian, grabbing any OPC compliant data, packaging it, and sending it on. So much less horsepower required to do that. As mentioned, we actually do the software updates for you. There's no on-site, on-process migration, same sort of thing you see in web apps. There are lots of updates happening all the time. If I think about Amazon, they probably did 10 updates today, and in a constant state of improvement. So that's a good thing. We mentioned kind of the democratization of the data, so not locking the data at an L3 level, let's say, where only folks with that access can see it. We're going to provide it in this platform so that everyone at a site, potentially corporate folks, could see it as well. So single version of the truth and getting the information out there. This is actually old news now. We are actually APC technology agnostic, so that means we can support many vendors APC, anything that has a dynamic multivariable control structure with a economic function optimizer on top of it is fair game for this approach. And we actually offer it commercially on a subscription basis. You don't like it, you can stop renewing. So, you know, traditionally in this space, a lot of vendors sold a perpetual use, you know, it's a big install, things like that. This is a little different from that standpoint. I mentioned Forge and our new, relatively new branding there. I'm showing a screen right now which actually brings together process, assets, and advanced control in a single view. So again, we think there's value in itself in having a single view to these sort of different lenses on your process operation. Performance would be concerned with things like you know, catalyst health, or you know, are you realizing the profitability, the yields that you should be from a process? Assets, of course, looking at things like pumps, valves, and compressors, heat exchangers, and finally on the right-hand side, the APC area. You know, the other applications, the process and assets, have a similar workflow where not so much just around KPIs, but really driving a workflow, making actionable recommendations. So as I was saying, in and of itself, we think there's value in displaying these all this data through a common view, and then also it opens up the possibility for analytics to do cross application analysis. So right now, this is our Forge platform with these 3 items. In time, we will bring in aspects like alarms, like your regulatory control, PIDs, etc. And so that's will really, I think, really change the game in terms of having a more holistic view of a plant and being able to, maybe remove some of the silos around that have traditionally existed. Let's say my alarm, rates and so forth were in one application, my PID health in another, my EPC in another. Bringing it all together, I think, is really the direction that the market's going, and Honeywell is right there with the Forge offering. So I just have a slide on how to get started if you're interested. So we have a number of solution consultants. Honeywell divides the world into three poles, I guess. So in the Americas, Asia Pacific, and EMEA, some names there. As was mentioned, we will be making the materials available to you in about a week's time. So grab a screenshot or download the material when they're available. So lots of points of contact there. If you are an existing Honeywell customer, certainly your account manager is a good place to start. Tell them you're interested in the Profit Performance Monitor, and we'll get you the support you need. So I think we're on to the questions now. So Kevin, I'll hand it back to you.
Well, thanks, Gary, and we do want to urge our listeners to send us additional questions. We have quite a few, and we have some time to go through them, so we welcome more questions. But let's get right to it. One of our listeners' first questions matched my first question, and they say there are many definitions of APC, and it might include incorporation of expert systems, fuzzy logic, model-based controls. It's a process optimization control strategy, obviously, but I think you addressed this during the course, but let's make it more explicit. How do you define advanced process control, Gary?
Well, I think anything with an underlying model, I use the example of a dynamic model, a time series model, but it could very well be fuzzy logic. In the end, the problem we're trying to solve is that there's this pretty high-tech piece of application that at the end of the day is being used by operations, right? Generally on a 24/7 basis. So the problem we're trying to solve is to figure out what good APC usage looks like. And that is just as relevant on a application with underlying fuzzy logic, expert systems, as it is on a time series based dynamic controller. Anything with that control on the lowest level and some sort of optimization driving it, which most applications they have, is fair game for this approach.
And would you say that multivariable control is found in the greatest number of examples?
Yeah, I would say that in my experience. I mean, I'll say although Honeywell, we play in a lot of different verticals, not only hydrocarbon processing, but pulp and paper, mining, fuel, ethanol, etc. My experience is that advanced control has generally that sort of time series dynamic model sort of underpinning to it.
Good. Another question. Someone asked, the 3 main causes of APC degradation didn't include degrading instrument and basic regulatory control. Don't you consider these to be major causes?
Yeah, it's a good point. I didn't state it explicitly, but my third cause there, where there's maybe a slowly integrating issue over time that may result in a reduction in the process window, I would sort of put in that category. So if you had a PID controller that can no longer achieve the range of flow, let's say it's a flow controller, as it could in a starter run or post-commissioning status, then it would tend to show up as sort of a narrowing window over time of that operating envelope. And while there's the root cause of that is really to try to address the regulatory control or instrument issue, we do think there is value in highlighting the fact that there is the result of that will be felt by an APC application and result in lost benefits over time.
Good. Another question, when you're talking about identifying or what is the main condition in finding degraded, here the questioner asks, what is the main condition in finding degraded APC performance?
Yeah, that's a good question. So I would put it in the buckets as described as limit management, the APC status, and partially disabling the APC application. Those are the three main ones. The limit one always kind of was, in my experience, both with Honeywell and before Honeywell, can be the hardest one, maybe the most persistent problem. You know, there's a tendency, look, if you're on a shift for 8 or 12 hours, you want the shift to go well, right? And sometimes the perception is by narrowing a window that, you know, you'll stay in a safe point of operation. And while there's some merit to that, at the end of the day, we think customers do want to move out, not to the ragged edge of process, but at least achieve what the process is capable of. So that issue around limits is probably the one I would say that is the hardest. And, you know, I always felt as a control engineer, I was burning a little bit of goodwill every time I went out and I talked to the operator and said, hey, you know, that pump around flow, I noticed you changed the limit to 35. Do you think you could set it back to 38? You know, there's a little bit of goodwill lost in that because I couldn't really say why other than that was sort of the design conditions. The nice thing with Profit Performance Monitor is we can quantify it, right? We can go to an operation supervisor or superintendent and say, hey, that move of that pump around, that's cost you $500 a week. If you want to go and chase that, we think you should care about it. You know, let's get it back to what we consider the ideal and proper value.
Good. Perhaps this is a related question. When a process reaches its ideal point of operation, presumably near its limit, should its performance also be stable?
It should be, yeah. Generally, stability is one of the driving factors of APC. You know, it's. I'll make the cruise control analogy, right? Like the cruise is running a lot more frequently than I could. Most APC applications run in a lot of continuous process industries at maybe a 30-second or 1-minute frequency. So, you know, to ask an operations person to monitor the process so closely that they can make, you know, perfect control adjustments on a minute-by-minute frequency on a unit-wide basis, it's an unreasonable ask, right? So typically what happens is the operators make very good moves. They'll just move the key variables at a slower frequency, maybe once per shift, a couple times per shift, you know, as needed. So all we're doing is kind of doing similar to what the operator would do, but doing it on a more frequent basis. And those frequent adjustments is really what helps to stabilize the process, to reduce the variability of the process. The other aspect, of course, is that these controls are multivariable. So instead of having simply one handle to control the process, potentially we have more handles, and they're also kind of predictive in nature, so that if we can measure a disturbance, we may actually be able to take action before that disturbance is seen in the process, or at least minimize the effect of that. So those things combined should help to drive a reduction in variability.
Well, thanks, Gary. One of our listeners has a political question. Who should own or drive the APC program? A process engineer or a control engineer?
Oh, that's a very political question. So I think, as I said, they're all interested parties, but it's interesting to me that you didn't mention the operations supervisor, the person who might manage the on-shift person. We think he's maybe been sort of an underserved person in the space of APC maintenance, right? That, you know, it's in the end of the day, he's the one who manages the folks, and we think if we can get him the right information, say, hey, you know, that unit that you are gold on its performance, we're going to provide a tool for you to help to realize better performance. We think he's going to be an interested party as well, and hopefully short circuit some of these issues that do tend to bubble up currently to maybe the control or process engineer.
Good. And how do the role of the process engineer and the control engineer contrast?
Yeah, control engineer really, as the name says, his mandate might be, you know, tuning the regulatory PID controls, maintaining the advanced controls, implementing more advanced controls. He really has to have a knowledge of the process, and that's what drives the controller design. You know, as I mentioned, a good control engineer, he's really trying to mimic what the operator does, but just design controls that do it more frequently and consistently. On the other hand, the process engineer, he might be looking a little bit more longer term. Things like, you know, can the process handle different operating conditions, different types of feeds? Is there a better catalyst? Is there a turnaround coming up where they need to do some maintenance activity and plan that? So that's how I would contrast those two roles.
Good. One of our listeners asks, is there value in doing an on-off test to estimate the benefit of the APC?
Yeah, certainly. Well, let me answer that. So I know this is often advanced as one of the proof tests of APC. I'll say a couple things on that. One is that if that's done after the APC is commissioned, it often shortchanges the value of APC itself. And the reason for that is, in doing an APC project, you really probe into the process. You figure out what should we be manipulating, what should we be controlling. Maybe, as one of the other listeners mentioned, maybe there is a regulatory control problem that would stop us from implementing APC, and we'll get that addressed, right? So the accumulation of benefits starts at the kickoff meeting, in my opinion, on an APC project. So I've heard it suggested that, well, we're going to commission the controls, and then a month later, I'm going to turn them off and then see, you know, where the process goes and measures it. In my opinion, that's sort of shortchanging the value of APC itself. The proper conditions for the baseline are actually before the kickoff meeting of the APC project ever happened. So I'll say that. And then the other point is that there is a cost to doing that. If you believe the APC is delivering benefits, if you turn it off for a week or a month, then you sort of absorbed a lot of cost in sort of proving at that point. So we'd rather advocate for maybe something like a post audit that measures the APC performance, contrast that to the pre-project performance as maybe a better way of establishing the benefits of APC.
I thought it was interesting when you talked about comparing shift performance that one of the likely reasons for that would be that they simply had the APC off. Is there ever, are there legitimate reasons why at times it's best to turn the APC off? What might be the reason for doing that?
Yeah, that's a very good question. So I'll make the airplane autopilot analogy here. So although I understand this is changing as well, but generally takeoff and landing, you want the pilot to be in control. He's flying the plane. The autopilot is really built to the point where you get up to cruising altitude. It's going to do a great job on heading and speed and fuel conservation and all those things. That's really what APC on a process is built for, that sort of, relatively steady state. If there's something unforeseen, unusual that happens on the process, say, the feed pump is lost or something like that, that's a perfectly legitimate reason to drop APC. APC is really built for that 99% plus of the time when the process is fairly stable and normal operation and can deliver plenty of benefits in that time. But yeah, there's definitely times where, hey, look, these are conditions where the operator has to take, unusual, super quick actions, and APC should be off. Some people even programmatically may detect a condition, right? Hey, my feed rate has dropped to this. I'm going to shed APC automatically and make it a little more easier for the operator to manage that situation.
Good. And another thing I'm curious about is how often is it that there is meaningful, quantifiable differences between shift performance over a significant amount of time?
Yeah, that's a good question. I should say this application is relatively new, so we don't have a huge data sets yet on which I can draw on to give you a really good answer. But I think we're going to find some things based on maybe demographics, maybe driving some of this, right? Like certain people with a lot of experience may operate the unit in a different way than someone with less experience. I've heard a less experienced person may tend to let the APC kind of drive the unit, where a more experienced operator who's maybe has process experience before the APC was even implemented has some ideas about the best way to run the process, what they've seen historically, right? So I think we might see a bit of shift-to-shift variance, perhaps tied to operating experience, but it's one of the areas that I'm really interested in finding out what exactly this tells us and how to make best use of this data.
Good. One final technical question and then a wrap-up question. Someone asks, is access to the dashboard through HTML pages or over the internet?
Yeah, it's a web browser session. You'll get a login, and that's how you view the dashboard. Yes. Good.
My final question is about the financial analysis. I mean, obviously, throughput would be a gross indicator of financial performance of a unit. I'm assuming that the analysis that you're doing here is more sophisticated than that. And I mean, having these kinds of financial analysis in real time has always been kind of a holy grail. How much advance do you see as being embodied in this system? And what's interesting to you about that aspect of it?
Yeah, good question. So our profit function that we build is more complicated than just the feed rate. Typically, we'll build a profit function that considers the value of the products, and a lot of process operations make different products at the same time, so we'll put different values on each of those. The feed costs, some of the utility costs, and that's what comprises our profit function. It's interesting to me because a lot of APC that you'll find out there, although it could have been initially designed with that level of complexity of the economics, typically isn't. You know, the objectives may be expressed very simply as minimize this variable, maximize that variable. So while that drives the right behavior, it doesn't quantify, you know, in absolute or even incremental terms, the value of the application. So we see one of the side benefits of doing this is a better understanding of the economics that are should be driving the advanced control. And I'll just state real quickly, Kevin, that one of the questions that comes up is, do I have to change the technology of my APC? And, hopefully I've addressed that. No, and we can monitor any APC technology. The other is, do I have to redesign my APC to take advantage of this? And again, the answer is no. That profit function, while we'd like to see, you know, the on-premise APC application have a similar profit function, it doesn't have to be. We'll build that in this Forge environment so that it doesn't require a redesign of the APC.
Well, thanks, Gary. I really enjoyed listening to your presentation. That's all the questions we have time for today. Thanks to Gary, our expert presenter, and thank you all for attending today's webcast. We hope it suited your purposes. For more information, please go to honeywellprocess.com. I'd like to thank Honeywell Process Solutions for sponsoring today's webcast, and now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as this webcast ends. Please take a moment to complete it as we use this information to improve our webcasts. On behalf of CFE Media and Technology, thanks for attending, and we'll see you next time.